Thank you. Cool. All right, so I would explain what I do, but I was like so excited by Naomi's little sort of visualization of the mission of eLife. I was like, oh, that's my job. I am that platform at OHSU, so it's awesome. So thank you for that. I want to start by telling you sort of a little bit of an origin story of why my colleagues and I sort of embarked on this study of journal data sharing policies, both from a specific instance and then sort of more generally why we care. So about a couple years ago, the Tianyi Mao lab approached me and the OHSU library with a frantic and urgent plea to help them publish their data. And they had submitted an important paper to Nature Neuroscience, and Nature Neuroscience had accepted that paper. And at the same time, another lab had submitted a paper on the same topic with very similar data. And as you know in science, for better or for worse, who is first really matters. And the sort of like finish line is whoever could get it publicly available first wins. So they needed our help in getting it publicly available. Move. See, this is when the technology fails. But this data, as all data is, was pretty complex. So the data concluded hundreds of images and moving images files and analyses that were aimed at trying to understand the connections between the thalamus and its targets in the cortex. And do not ask me any more about that. And so it was hundreds of images that ideally should be viewed within a viewer that offers sort of a three-dimensional view of these images, and it was terabytes and terabytes of data. But we were actually able to do it. The lab brought over physically to the library multiple hard drives with these images and the analyses, and we, over a week or so, like slowly loaded them into our institutional repository. And we were able to help them get their data up. It was in a public repository, it was open, and Nature thought that was just fine, and they won. They published their paper, and Jeannie, who was in the last session, it was actually the last paper that she published, or first paper, I guess, published, and then she graduated. So it was a huge success. It was awesome. But the solution we provided, while technically open, functionally it was not. It really did not facilitate reuse. And Max was here on Monday, and we were in this open source meeting, and he coined the term clopin, which I think is just like the most amazing thing, and I've been using it ever since, wherein you have this data. Ever since Monday. Yeah, right. You have this data that is, technically open, but when you really think about the reason why we advocate for open, it doesn't meet the mark. So the other reason why we care about that mouse, and we care about this issue, and you've probably seen this slide like 5 times now or something. So anyway, is that I work in the ontology development group at OHSU. And the bread and butter of our group, why we exist, is to facilitate translational research, meaning that we're trying to take basic science discoveries and advances and move them over to the clinic to advance human health. So in the case of Jeannie's mouse, we want to take that mouse to the bedside. But the kind of solution that we provided for that Nature Neuroscience contributes to siloed and disconnected and really hard to use data. So this is Melissa, our PI in the ontology development group, coined this term, the chasm of semantic despair. So there's this big gap between how we often share data and what that data is actually enabled to sort of do and facilitate. So ultimately what you want to have is what Naomi already talked about. You want solutions that achieve and facilitate fair data. So data that is findable by both humans and machines, data that is accessible by both humans and machines, interoperable and reusable. And there's like an array of workflows and solutions and practices that facilitate fair data. So this is a story, the end of a story that my 4-year-old recently wrote. I do not know what it says about my parenting, but I will say that it completely reminds me of sort of this like badge of openness that we often use. So we talk about open science and we talk about data, open data, and it's this like sticky shield that everybody can get behind. But when we don't have the practices and guidelines and infrastructure that facilitate fair open data, you've sort of like killed it. Data goes to die if it doesn't have an infrastructure and a wrapper of description around it that facilitates reuse and enables why we make it open in the first place. So we've talked a lot, and Naomi sort of described this as well. So we have this broad agreement about how important open data is. And that's reflected in emerging policies. That's reflected in what we're seeing from publishers in terms of sort of the guidelines that are starting to emerge. It's reflected in what researchers report they understand and know. Unfortunately, it's not yet reflected in our practices. So there's this gap wherein we sort of have this sort of collective buy-in, but we're not yet putting that buy-in into the best practice. So my colleagues and I were very interested in this for the reasons I've already described, and we were particularly interested in really sort of digging further into that sort of scenario that we encountered with nature. It's like nature has a pretty robust data sharing policy. What does that look like elsewhere, and how is it that nature accepted this like crap solution to sharing our data? So we started looking at that. So what we did is that we are specifically, given where we are, we're located at OHSU, pretty much interested right now in the biomedical literature. So using journal citation reports, we analyzed 318 journals that had a subject classification that would sort of fall under biomedical research. And we limited our sample set to journals that fell into the top quartiles for either publishing volume or impact factor. And we did that because we sort of wanted to get a sense of, but just the sort of sheer scope of what was being published, capture sort of a lot of that activity, but we also wanted to understand this from a sort of a prestige perspective. We utilized a rubric developed by Victoria Stodden and her colleagues, which they published a few years ago, that was looking at computational research. So we started at the top with very explicit policies that have data publication as a condition of publication, without any exceptions, or barring exceptions like PHI, for example. And then down to the bottom, number 6, no mention. We also looked at some characteristics of the journals, for example, were they open access or not. We also wanted to look at and sort of be able to tease out structural data like proteomic and omics data versus more general data sets, because previous work has told us that for structural data sets, sort of the data sharing requirements is a bit more mature and robust, and we didn't want just looking at that to sort of skew the overall picture of what we were finding and sort of trying to understand. We also looked at where are the guidelines asking researchers to put their data. So is it in a public repository or inside some guy's basement in his hard drive, right? So like that matters. And then, this is just sort of another dimension of that, a little bit of detail there. We also wanted to know what kind of licensing was being recommended or even discussed for data. So was the guideline recommending or even bringing up CC0 or CC BY as an option for the data sharing, or was it not addressed at all? And then finally was archival and retention policy addressed. And then sort of as an interesting dimension for ourselves, we were wondering if when sort of articulating these policies, if the journal was sort of framing them within the, sort of under the framework of reproducibility, which for better or worse as well, sort of like the sky is falling, is where many of these policies really started to emerge and gain a lot of discussion and sort of like popular science news. All right, so this is what we found. So here we have just a look at what we found in terms of just the prevalence of data policies, and does a journal have a policy along sort of our 6 dimensions. So we found that unfortunately the journals with a very strong data sharing policy, that very explicit data sharing policy, were only 11.9%, so about 12% of our data set. And if you look over to the right, you'll see that the bulk, over 31%, had no mention of data sharing. We also looked at this in terms of publishing volume, because we had all of that data as well. So maybe it looks pretty dismal when you're counting the number of journals, but when you're looking at sort of the overall publication volume and sort of what's actually being communicated, doesn't look any better. It does look a little bit better. So when you look at it for the publishing volume, sort of the number of citable items, it jumps up to 32.7%. Had a strong data sharing policy, that category 1. However, most of that is PLOS. So if you take out PLOS 1, that drops down again to about 11.3%. And that doesn't mean those PLOS papers aren't real. Obviously they are, but it does, it creates sort of, you need that context to really understand what's going on there. All right, so we also wanted to look at impact factor as it relates to data sharing policies. So we did find that impact factor, there was a statistically significant association between impact factor and the presence of a data sharing policy across most of our categories. So for that strongest data sharing policy, the average impact factor for those journals was just above 8. For those without a data sharing, mentioned data sharing whatsoever, it was just over 3. And that sort of trend continued when we did the statistical tests across these different dimensions. And I think it's important here for us to describe that we don't view this as an indication that higher impact factor journals are better journals, but that there might be other reasons why we're seeing this association. But at the same time, this could be a lever for advocating for more journal data sharing policies, and also for putting in front of people that are skeptical. You can say, the journals that matter most to you, whether I think they should or not, require this. So it's actually something we've used a lot at OHSU. And then sadly, actually, another dimension that we looked at, because so often in our discussions about how to improve transparency, reproducibility, public engagement, and trust with science, we pair open access to the literature with open data. They're sort of partners in that transformation. But sadly, we found no significant association between the access model of the journal and the presence of a data sharing policy. So let's hope in something that we actually hypothesized would be different, but it was not. We looked at where data was recommended to be deposited, or the method of sharing. So good thing is over 60% recommended through a public repository. Bad thing is still quite a few didn't recommend any specific method. And I would say also still in a sort of a disappointing way is that there were a high percentage that recommended sharing through the journal itself. And I will say a lot of those numbers are Elsevier. I'll leave that there. And then finally, that other piece, and when we're thinking about sort of that fair data landscape, Something else that showed up as really broken is the overall lack of guidance on licensing and archival retention. So even for those journals with a very strong data sharing policy, there was a minority of instances when they spoke to data licensing, and I believe only 2 of the journals in our entire data set specifically addressed archival retention. Okay, so a few things like closing comments here, and I also talk about maybe at the end what we didn't look at that we should have. But so like, how do we improve sort of this state of affairs? And I don't mean to like present like I'm excited about open data. I love open data, but there's a lot we can do to make it more impactful. So a few things about like how can we get to a place that we love our data more and that we get scientists and enable scientists to view it as an asset as important as their papers. So first, this is our GitHub repo where we have our data, and we'd love for you to love our data and add to it. So something that we would like to do is really build a community contributed repository of data sharing policies for journals that we can not only add to sort of the corpus we've already established, but we can track change over time. We'd also need to build out our rubric. You notice that we didn't talk about metadata. It's like, why didn't we look at that? But we didn't assess the policies for how they're addressing metadata, for example. So there's ways in our work specifically can be improved. So we'd love for you to love our data. But what do we need to give researchers? And we really need to give them all the stuffs. Because, and I think sort of Naomi's talk spoke to my heart in this way, is because there is no magic bullet. A journal data sharing policy isn't going to solve this problem. Upstream education alone isn't going to solve this problem, and neither are badges. It's sort of this modular complex of all these different solutions that some researchers are going to need some of these and they're going to need some of that are really going to get us to a place that data is not only more open, but it's more reusable. So some things that excite me and sort of speak to that spectrum is projects like DAT, right? So projects like DAT make upstream collaboration and versioning and sort of preserving and articulating and documenting the environment in which data is created easier to do. It's essential. There's a Center for Open Science and the top guidelines that they've established. So the top guidelines are the, oh my God, transparency, openness, promotion, thank you, guidelines. And they, on sort of several levels and via pretty easily to understand schema, recommend certain practices that journals and repositories and funders can take to facilitate not only open data, but reusable data. And I can envision taking those top guidelines and moving them into some sort of boilerplate language that publishers could easily adopt in the sort of the journal domain space. The Reusable Data Project is a project that Melissa Hendel, our PI, and her collaborator at LBNL, Seth Carbone, have started with the support of NCATS. And this project really aims to dig into the importance of licensing in data sharing and data reuse, which obviously I already talked about the gap in the policies. So as you read there, it aims to engage the community around discussion, but it'll also include a star rating for data repos and the licensing attached to those repos and data sets that really indicate sort of with 1 star, you can't really reuse it at all, to I think 5 stars when you'll sort of the licensing language really facilitates both human and computational reuse. And then just a little bit about context. If you were at the keynote talk yesterday where she brought up that picture of the cow that some of us could see and some of us could see. And so we really do need to be able to see the cow. And that's meaning that we need to be able to facilitate simple but robust description of data sets that fit in and are facilitated sort of along that sort of spectrum or cycle of data creation. And projects like Mantle that were discussed yesterday in the talks, wherein researchers will be able to sort of, it sounded like my dream world, like a drop down of ontologies that is inferred from the data that people can apply to their data set. It's like magical. But it's tools like that and some of what Naomi described that I think will really sort of move the needle on, I think Heather talked about in her talk, is like openness for the, and you sort of finish the sentence there. In our world, it's human health, but there are lots of other use cases that data can facilitate. And I'm done. So,